morning, Principal Sheep. Whee! Welcome back to our classroom. Today, we'll be learning about terminal velocity and combining forces. Whenever there are multiple forces acting on an object, it's not enough to talk about the size of each force. You need to know the directions as well, so you can figure out which way an object is moving. I'll give you a few questions to see if you understood. What else do you need other than the size of each force? Why do you need something else other than the size of each force? You need the directions of the forces, because you need to figure out which way the object is moving. There are two main quantities/unit types you need to know: vector and scalar quantities. Vector quantities are force, velocity, acceleration, momentum, and more. Their units have a size and direction. That's what makes them vector quantities. Scalar quantities, on the other hand, are mass, temperature, time, length, and more. Their units have only size, no direction. I'll give you a few questions again. What are the two main quantity types called? And what are they? Like the definition and a few examples. The answers are vector quantities and scalar quantities. Vector quantities are force, velocity, and acceleration. This is because the units for them have both a size and a direction. Scalar quantities are mass, temperature, time, and length. This is because the units for them have only a size. Now I'll talk about combining forces. I'll give you a question to test how much you know. Just give it your best try. To work out the resultant force, you need to combine the vectors given to you. I'll explain this further with the help of an example. What is the resultant force of 210 force north, 120 newtons force south, and 15 newtons force south? Give it your best try. The answer is, to find the resultant force, you need to minus 120 plus 15 from 210. 120 plus 15 is 135. So 210 minus 135 is 75 newtons. Since the 210 wasn't minus from 120 plus 15, if the answer is positive, which it is, the direction is going north. Also, the 120 newtons and 15 newtons are added together because although they are different forces, they are headed in the same direction. Terminal velocity. When an object starts to fall, it has much more force, accelerating, than the resistance slowing it. However, as the velocity increases, the resistance starts to creep up. Eventually, the resistance force becomes equal to the acceleration force, making it unable to accelerate further. This means that the object has reached its maximum velocity, also known as the terminal velocity. I'll give you a few questions to test how much you understood what I just said. What is it called when an object can't accelerate anymore when falling? Explain how an object would become unable to accelerate further. The answers are reaching its maximal or terminal velocity. An object starts to fall. The acceleration is at an all-time high, the resistance at an all-time low. As the velocity increases, the resistance increases. Eventually, the resistance will become equal to the acceleration. Then, it won't be able to accelerate any further. The accelerating force that acts on all falling objects is gravity, and it makes all of them accelerate at the same rate if it wasn't for air resistance. We know this because on the moon, where there is no air, rocks and feathers dropped at the same time hit the ground together. I'll give you a few questions to test your understanding. Prove that air resistance is what is causing everything to not fall at the same rate of acceleration. This is true because on the moon, when a rock and feather is dropped simultaneously, they reach the ground at the same time. However, on Earth, air resistance makes things fall at different speeds, and the terminal velocity of objects is determined by the drag it has compared to how much it weighs. The drag changes depending on the shape and area. I'll give you a few questions again. What affects the drag? How is the terminal velocity determined? The answers are the shape and area. Drag compared to how much the object weighs. The most used and important example is a human skydiver, like the guy on the right. Without his parachute open, he has a small area, and a force that is equal to his weight pulls him down. He would reach a speed that is very dangerous to land with, and he will go splat. However, with his parachute open, there would be more air resistance because it gives him a larger area, but the same amount of force is pulling him down. This means that his terminal velocity comes way down, giving him a speed that is safe to land on Earth with. I'll give you a few questions to test your understanding. What is the most important and used example? Why is it safer for people to have their parachute open? The answers are a person skydiving, and because the parachute gives them a larger area, but the weight pulling them down is still the same as before their parachute was opened, so it gives them a safe speed to land with. And that is it for today's video. Please like and subscribe if you learned something new. 3, 2, 1.